So we can begin with Aditya L1. As obviously it is your child, and what are all the challenges that the mission team faced while developing and launching Aditya L1?
Aditya L1 is actually an observatory class space mission. So 20 years back almost, when we started thinking about a solar mission, initially it was only planned for a small satellite program in a low Earth orbit. But then with our Mangalan success, ISRO wanted to have a more challenging mission for studies of the sun. So we were given this opportunity to go to a location called Lagrange 1,
Okay.
which is 1.5 million kilometers away from the Earth.
Okay. Oh, that's why L1 is.
That is why
Okay.
it's called L1. So
Okay.
for a two-body system, there are actually 5 Lagrange points.
Okay.
And Lagrange 1 is a location between the Sun-Earth line,
Okay.
and it is about 1.5 million kilometers
Okay.
away. And if you can reach around L1 and make a orbit around L1, then you have a continuous view of the sun.
Okay. So do you have the measurement of L1? How many kilometers? Like
Yes. So this is again a theoretical calculation. So it's a sort of imaginary point in space.
Okay.
It's a mathematical concept.
Okay.
So it was also very challenging to how accurate that calculation is.
Okay.
So of course it was very challenging to reach Lagrange 1, because there are only very few nations, namely the Americans and the Europeans, have been able to reach Lagrange 1 point. So technologically it was quite challenging to reach L1. And once you reach, then you have a continuous view of the sun, and you can really study whatever happening around the sun in the solar atmosphere.
Okay.
There are dynamic things happen on the solar atmosphere. Namely, there are storms, and these are huge explosions in the atmosphere.
Hottest star.
Hottest star. So, of course, this is our central star,
Yes.
and we are thankfully away from it. But these storms, when they come from the sun, they can reach Earth.
Yes.
And before it reaches Earth, there are assets in the space, namely the satellites, so they can directly get impacted by these storms.
So these storms can impact our even gadgets like mobile phones and television, like.
Absolutely, not directly, but they will impact the satellites.
Okay.
But the satellites are only sending you a signal.
Yes.
So if the signals are interrupted
Yes.
while they are transmitting from the satellite to your
Okay.
device, your transmission get blocked. And it can be, so it's a GPS can get disturbed. So all sorts of communication satellites can be damaged, and the satellite itself can be permanently damaged.
Okay.
Because these solar energetic particles, they impact with the satellite hardware, and that can sometimes temporarily, sometimes permanently, at least the life of those devices get reduced as well. So it is important today to really protect these space assets from these solar storms, to understand why a solar storm happens, and if such a solar storm happens, whether it is going towards Earth or not. All these understandings are very required. So for that, we have this space science mission with the possibility of remotely looking at the sun to see when such explosions will happen. And when such explosion happens, when the particles come, before it reaches Earth, it will go through our satellite at Aditya locations, and then we will be able to characterize the properties of these energetic particles, the kind of magnetic field it is carrying, which will allow us to understand the impact of the solar storm.